So in last class we discussed about the difficulty of problems, right? So we understood what is our real problem. So, right, there are some certain problems we can't solve, right? So there are some certain problems we can solve. So those problems we can solve in polynomial time. That is basically some limited amount of time that will be very easily we can calculate. But whereas we require exponential time, so which we can solve in polynomial time, we will name them as p, and we will make them as exponential xp, and which can be solvable in finite time, those we are calling R. After this, those problems are unsolvable as of now. In between these, we have the word NP, non-deterministic polynomial time, right? So this is P equals to NP or P not equals to NP. This is a millennium problem, right? Let's imagine you are the owner of the one theater, cinema theater, okay? So people are waiting outside of your cinema theater, more than 500 people or 400 people, but your cinema hall capacity is only 100 or 150 members only. Your hall capacity is limited, 100. Let's imagine 100. But outside of your theater, there are more than 100 people. Let's imagine 500 or 400 people are there. So this is simple. You can choose any one of the 100 members and you can give them tickets. But if you complicate the problem, let's imagine you have a list of one paper. That paper contains incompatible pairs of viewers. So you have one paper with you. That paper names, out of these 500, some of the names you are having in that paper, those pair is not incompatible. So you can't. So while selecting your 100 members, you need to make sure you should not include these 100 pairs, incompatible pairs, into your final list. So this is also hard problem. We will, in computational computer languages, we will say this is hard problem. So, but whereas if someone gives you 100 names, members list, so what is that mean? Someone created the final list of out of those 500 based on this, based on your incompatible list also after eliminating. But once you have the solution, or once you have the list of 100 people, you can cross check, right? You can cross check whether these people are there in your paper or not. That is easy. But to come up with the list combination, how many combinations we can prepare, how many combinations we can have to come up with that solutions, right? It will take a lot of time. That is very hard problem, and we will call that as NP, non-deterministic polynomial time. Because as I said in last class, anyone remember, right? I hope you remember. So what is exactly we are doing? We are non-deterministic because we are relying on some luck that will always gives the solution, right? Yes. So that is what non-deterministic polynomial time. And exponential. So the difficulty level we understood. Now we won't discuss all the problems how to solve, but in next classes we will see. But for today class, I just want to make sure we will give some more idea on what is meant by polynomial, exponential, those problems. Okay. So in while we are discussing about functions, the graphs, functions, right? So we learned that if this is a graph, constant, linear, right? Linear, log n log n, or 2 power n power k, this is what? K power n. So this is constant, this is n log n, like that. See, these are our concentrated area. We are always try to make this problem solvable as like this. Like this. Always we want to try this exponential problem as polynomial problems, right? So this is the order. If you are solving one problem in computer language, so that how we will measure? We will measure using these functions. One of the functions, it will be false. When you are solving your problem, you will spend one of these amount of time. So polynomial time examples like insertion sort, merge sort, binary search, matrix multiplication, those things will come under polynomial time. Okay, so these problems can be solvable in limited period of time. Okay, but whereas hard problems like exponential problem, just I mentioned, you need to prepare you need to allow 100 people into your cinema hall theater, and there are n number of problems. We have chess. If we increase the number of rows and number of columns, it will become as obviously very hard problem to solve, right? Those are exponential problem. And Hamilton circuit graphs, those things also, and we need to find the shortest path. Those are many problems are there, very hard problems are there. We are still trying to solve those problems we are trying to solve them in polynomial time, right? That is our idea. Okay, so now if you see, this is constant is lesser than log n is lesser than n is lesser than n square, n cube lesser than, what is this, n power k. If k is some number, this is polynomial time. This will be lesser than 2 power 2 power n. So you will say k power n. So this is exponential up to this. These are, we can say we will solve in very limited amount of time. But whereas these k power n problems require lot of amount of time and lot of resources it will consume. Okay, these are the functions. If you are solving one problem in computer language, we will fall into one of these functions, that complexity basically, right? P, NP, XP, or after this we can't solve these problems. We always try to pull these all problems into this set so that we can solve many problems, right? To solve these hard problems from here onwards, this section, we will, people trying for different kind of options. One of the approach is reductions. Let's imagine, for example, you have one problem here that is hard problem. This problem came from this set. That means it's hard as other problems in this set. So to solve this X problem, we doesn't have any clue and we are unable to solve even though you spent 1 month of time or 2 months of time. Then we have some other approach that is called reductions. Reductions means you have another problem called y. Just imagine we have another problem called y, but not like x. You know how to solve the problem y. How to solve this problem by using some approach, some steps. You know how to solve the problem y. But whereas x problem to solve, you doesn't have any clue, but you have a feeling of we can convert this problem as y so that it will also solvable. So what exactly we are doing here? We doesn't know how to solve the problem x, right? And we know how to solve the problem y. Then we are trying to see, is there any relation between these? Can we convert this x problem to y so that if we solve x in the way of approach of y, that means we are solving x, even though I does not know anything about. So what exactly we are doing here? We are converting x problem into y. So this process we will call it as reductions basically. So we are by using reduction approach, we will solve one clueless problem by solving with another problem y. So this is called reductions. So we will try to spend some time on reductions also, or maybe after some classes we will try to explore how to solve one problem by using x. If you know x, how to convert through y, okay, by using some graphs, and basically if we will see examples with graphs, okay. So I hope now you understood the concept of problem difficulty, and what is meant by reductions, what is meant by P, NP, XP, R, and what is the difficulty level, right? So our ultimate goal is what? Our ultimate goal is to solve the problems. Even though as of now we are unable to solve, we are trying to solve those problems in limited period of time, that is polynomial time. So if we can solve those complex problems, what is the advantage? We can utilize them in our day-to-day life so that many problems will solvable. But here just imagine I will give you one more example. When Japan attacked Pearl Harbor, one of the navy base of United States, when Japan attacked navy base, okay, what happened? So Japan sent war flights to Pearl Harbor to drop the bombs on Pearl Harbor, right? So before they declared war against Pearl Harbor, they sent some messages to their army, right? To Japanese army. What happened in that case? These US army received the message, but they unable to understand what exactly this message means. This message represents attack on Pearl Harbor, but because these people unable to understand, they unable to stop the incident. Because this problem that time very hard, right? This problem became that time very hard. So this is the reason we started like cryptography. This is one of the mechanism in cryptography, right? So now to do cryptography basically, right? When you setting a password for your bank account, just imagine when you are setting a password for your online bank account. So if you give 1, 2, 3, just imagine if you are providing 1, 2, 3, 4, 5 as your password, this can be crackable, this can be hackable, right? This password is very easy to identify. But as of now, many of our crypto algorithms, this cryptography. When you are, if you are giving this as a password, what we will do? This we will encrypt into some format by using some encryption algorithms. RSA algorithms, we have many different algorithms. What are those algorithms actually? So cryptographic algorithms, what are those? Blockchain, these cryptographic algorithms should be as complex as exponential. It should be as complex as, it should be very much difficult, more than polynomial time. That is means, to solve this, to crack your password, the hacker or the person require lot of, should spend lot of effort to solve to know your password. If, for example, if we somehow we solved these hard problems by some means, that means what? This cryptography won't work out, because we know at some point of time, if you know how to solve exponential problems, very hard problems, then your cryptography, whatever bank password you are giving as of now, can be hacked, can be understood by other peoples by within limited period of time. But as of now, whatever cryptography currently exists, that is created using some algorithms that makes the encryption process very harder, so that people can't understand very easily, right? So this is also, you can relate this. This is hard problem, right? I hope now every one of you understood what is the difficulty and what exactly meant by these problems, why we are solving, what is meant by polynomial time and what is meant by exponential time. Okay.